Hey, hi guys. Good evening.
Hi, Shiva. Yeah.
Hi, Hemant. Yeah, hi, Lakshman. So let me wait for a few more minutes. If there are any more guys who are joining, let's see. Hi, Anand.
Good morning, Shiva. I mean, good evening
Yeah,
to you.
yeah. Good morning, Anand. Yeah, started sharing my screen. So last week, um, so when we had the Java basic session, so we talked about from the basics like Java history and what is JVM, JRE, so this JDK, at least these terminologies, and basic Java primitive data types. We talked about data types. We have seen strings, arrays, loops, and the classes, objects, right? And methods. So how to declare the methods inside them. And we talked about constructors also. Okay. So now, in today's class, we'll see the OOPS concepts. So some of the OOPS concepts, the advanced OOPS concepts, like inheritance. So we'll see the inheritance concept. So inside that method overloading, method overriding. Okay, and these two comes under polymorphism. Okay. Next, abstract classes also we'll see, and interfaces. After that, we'll see some of the basic exceptions, collections and exceptions. Yeah. So this much of information is sufficient, at least to begin with some of the basic programming. Okay. So, and I also last week I didn't share the sample Java programs with you, but this week I kept under examples with source code in the Hadoop project. So in the Google Drive, the Hadoop training June, this I kept the Java folder as well. So which contains all these examples for all the topics that we are discussing, like so inheritance topic like inheritance test. For collections we have hash set, hash map, linked hash set, all these things. I might not be taking all of them in the session. Yeah, and reading a CSV file, reading IO operations, file IO operations. Even that I will cover here. File IO operations. So I will give it on high level. Just refresh the basics. Okay, I will just touch base them. So I want you to practice. At least you know how to load these programs into Eclipse and test them, right? So that's the reason why I kept all these things into your samples here. Okay. So example for abstract classes, append to a file, binary search. So these things you can try with them. Okay. So now, so let me get started with. So in our last class, we have seen class is a skeleton where you can declare all the attributes. Same like your, if you are representing anything in a table format, all those columns you can represent them as attributes in the class, and you can define the methods for them, right? So similar fashion. So let me switch my workspace. Okay, so one second, give me a second. Yeah, sorry guys. Okay. So whenever you feel like you have a common nature, like if you take the employee, all the employees are common. Under them, the special employees are like managers. So they can be, so the basic common nature you can put into employee class, and anything that are specific natures that you can put under manager classes. Similarly, you can take a person as more general. Person, he will have basic attributes like name, age, and if he is a student, he will have the course extra along with name and age. If he is an employee, he will have extra like department and salary. If he is a manager, so he will have extra like, so along with salary he will have bonus as well. Okay, so now even manager will have the name, age, department, salary and bonus. So but here the bonus is the only one that is specific to manager class. So remaining the common nature you have divided into the common. So in this hierarchy, if you categorize or if you put your objects in this nature, in this fashion, the topmost level classes will be the more generic, and the bottommost ones will be the most specific. classes. Okay, so here this person class is called as a parent class, and this employee or student are called as child classes. And also person class has superclass. These are subclasses. Okay, so here you can see vehicle is the superclass. Under that, car is a subclass, ship is another subclass, bus is another subclass, and something like that. Okay, so vehicle is something that is common for all the vehicles. So that is those attributes and those methods will be put in superclass. Okay, so all child classes follow is a relationship with parent class. Is a relationship means car is a vehicle, ship is a vehicle, and similarly you can see student is a person, employee is a person, and manager is an employee, right? That relationship, that makes sense. The child classes can override the states and behavior of the parent class, that we'll see. Now here we have a vehicle class. So class vehicle, inside this I have int size of this vehicle and color of this vehicle, and I have a method move. Okay, and it simply prints I can move on land, water, and air. And now I have a car class. Okay, so which extends vehicle. Even this is having the same attribute size, color, and move method. So I can move only on land. So here, last time when we created the objects for class vehicle, so this means the current, this keyword means the current class object, and super means the parent class object. Okay, so let's execute this. These are the next ones. Int method 1. So subclass super public subclass extends the superclass. Inheritance test. Okay, so I need the main method as well. So I will declare this, either this one, public class extends subclass. Okay, so I have a superclass here. Okay, so in this, have this. Let me show you this. Okay. So I declared a superclass here, and inside that the constructor for this empty constructor, there is nothing to do with this. Int a equal to 10 and method 1, which takes integer parameter and returns that. That's it. Okay. And here subclass int method 1 int I return I. So in this, let's see what this guy is doing. Like superclass object super, new superclass, and subclass. So he's trying to do all this stuff. Let me take this out. Okay. So object superclass object is creating here, and subclass object also he created and assigned to OB subject, and superclass for object superclass object OB is assigning a subclass object. So even that is possible. And OB super dot A. So since this is not declared as private, you can access from your object field, or you define a getter method for that. Okay. So now int method 1 of 5, it should return 5, and this should also return the 5. Now let me make this I plus 1. Okay, let me show you this. So here I created superclass object, assigned that to OB super, subclass object OB sub, and OB. Okay, so OB super dot A, so which refers to 10, and OB super dot method 1 of 5. So this one, and I passed 5, so I should get 5. Okay, and OB sub dot A. So when I refer to subclass object A, it printed me 11, and OB sub dot method 1 of 6. So whatever I pass, I am returning I plus 1. If I pass 6, it should return 7. So it called the appropriate method. So even though the method names are same, method 1 and here, and since this is a subclass object, it called this subclass method, right? Now, so these two are clear, right? OB super and OB sub, they call the appropriate methods. Now coming to this, so now if you see here, I have assigned a subclass object to the superclass. New subclass OB, and OB.A should it refer to the superclass or subclass? The fields wise, it's referring to this OB.A. It's and mostly the fields we don't generally access by just the object dot field name. So we'll have a getter and setter methods. Okay. So that might be a bit confusing. So for fields, it's referring to the superclass fields. And if you see here, OB dot method 1 of 7. So if it is calling your superclass method 1, it should return us as 7, but it is calling this method. So you assign the subclass object to the superclass variable. Okay. So ideally speaking, I should not have shown you this. This is the general scenario why we assign these things. So if there is any conflicting subclass method overridden, so that will get called appropriately, even if you assign it to the parent class variable. Or if you want to try this example, class vehicle. Let me define these classes also in this one only. Okay, and this is class vehicle class. This is your car class.
Shiva, this is Nitu.
Yeah, Nitu.
I have one question. What is the significance of declaring a variable as an object versus declaring variable as variable only?
Variable as object and variable as variable only.
Yeah, like why do we even create object if we can just have int size, char color? Then why do we eventually sometimes make object of vehicle to get the attributes?
Object of actually I'm not getting your question.
Okay, in the last class, like you were telling, we can declare the variable directly, like int size, int or char color, like in this example.
Yep.
And the other thing is we can create instance of an object for that class.
Yep.
And then we can,
yep.
yeah. So how does that differ, and why do we use this versus that?
Versus I'm not getting your question here. So what there are no two ways actually. See, this is your okay. So if I'm not wrong, if I understood your question clearly, so this is something like, so you're declaring, if you are from data warehouse background, so I can define you this way. So this is a vehicle table. So this is like schema. So I'm just creating my table with 2 columns. So size 1 column with integer and color with 2 character.
Okay.
So char or string. Let me make this string. Char means 1 single character.
Okay.
So now you should insert a record into that. So one such record, so int size 5 and color blue is one record. Int 10 and color white is another record. So initially what you declared, so it's a vehicle and it's a size, right? So size and color. So you have specified in your class, so till here your class name is vehicle and you have this many attributes, and how to, if there is any getter method for this or setter methods for this. Okay. And now creating an object means create a vehicle record with value 5 and blue. So this means one record is called like one instance of or one object. So this is another object. This is another object. Similarly, employee class means it's just a skeleton. So what are the attributes that an employee can have, and what are the methods that you can run on that employee? And for every individual employee, you should have a separate employee object.
Okay, yeah. Actually, they are very different. I was just,
Not actually versus. Okay.
Okay, thank you.
Yeah. Okay, no problem. So that's why I have a vehicle class here and I have move method. So if I call my move on vehicle, it will print me I can move on land, water, and air. And I have a car class which extends vehicle, but this is specific. This can move only on the land. This is generic. Vehicle is generic, so it can move on any. And this is specific. It can move only on land. Now, if I create a object, let me comment this out so I don't for some time. Okay, vehicle V1. Okay, so first vehicle V1, new vehicle, simply created this, and V1 dot move. If you call this, so it should print that. So now you are creating car C1 or car Ford equal to, so new car Ford dot move. Okay, and creating another car Maruti is another object. It's another car, right?
Okay, yeah, it's clear now.
Okay, yeah. So you are calling Maruti dot move. So just you're defining the attributes of your car here, and if you specify the values for them, then it will become the instance.
Okay.
Okay. So now if I execute this, okay. So the first on vehicle, if I called this move, it called the appropriate move method, and on this, it called this move method. So now, in case if I don't have this move method in my subclass, so if I still call this, so what will happen? So when I don't have the move method in my subclass, which is car, when I call the car.move, the Ford.move, I don't have move method in my car class, but I have it in parent class. Yes, I can access that.
Okay.
So all your common nature you can put in your parent classes. Only specific nature you can put in your subclasses. And you don't need to repeat that logic again here. Okay, only the specific logic you can put here. And even if you call the common methods on this subclass, they will get called from your parent class and they will return the appropriate messages.
So Shiva,
Yes, Anand.
is there a sequence I'm not that good in programming, so sorry. But question here is, the sequence is the parent class, then the subclass, and then you have in the bottom, right?
Yep.
So how does that work exactly?
The sequence? Sequence is not matter here. You can write them in any sequence. Thing is, you put your common nature in the parent class, just the class and class name, and define the attributes, define the fields, and some of the common methods there. And your subclass, you put that define a class and subclass name extends your parent class. So with this, it identifies, so this is a subclass or child class for this vehicle, not by the sequence.
Oh, okay.
Okay, so even if you declare it here, it will accept. And even if
because
okay, and even if I move this here, top, above the car class, even then it will work. See, it's not throwing me any error messages. So it's not highlighting it.
And if you want to explain the flow of this, basically you have a parent, you have a subclass, and then you have a working area. Where
Yep.
you call those both the classes.
Yep.
And what are you trying?
What are we trying to do?
Yes, that's a little bit not clear. Sorry, I know that it prints the dialog, the what you have written, it prints it out.
Yep.
But
So what I'm trying to do here is, I'm trying to keep the common nature in parent class and the specific methods, anything that is specific to children classes in the child classes. So I'm trying to call the methods on the child class. So if that method is present in the child class, that will get called. Even if that method is not present in the child class, but present in the parent class, even then you can call them from the child objects.
yep, got it. Yeah, that's clear.
That's it. Here, I have so move is fine. And if I want to override this method, so I don't want the parent class nature for me. Because if I call the parent class move method, it prints I can move on land, water, and air, but my car runs only on land. So to tell that, so I rewrite the method with the same signature. Okay. So with same signature, public void move, you have written in subclass also, and I have overridden this definition. So this time it prints only the, if I call the subclass method, so this one will get executed, but not the parent class, this one. So if the move method is not there in the child class, so you have seen that this is being called from the parent. Okay, let me put in the same sequence. So move method was not there in child, so it was being called from parent. So if move method, same parameters, if it's present in child, so this takes precedence than the parent one. That is what I'm trying to say here. So now you are defining the same method on the in both parent and subclasses, and you are creating a, I can assign my subclass object also to my parent class variable. Vehicle v2, I can create new car as well. And v2.move. So if I assign this, I have a new car object assigned to vehicle v2. So now if I call v2.move, so which one should get called? So here I created the new car object, this object assigned to this class variable. So now if I call v2.move, whether I should call vehicle.move or car.move. So can we have a subclass? Can we have a subclass inside a subclass? Inside a subclass. Subclass for this subclass, right? So your question is like this. So now you have sports car. That's not it. And sports car, extending the car. Okay. And extends car and fuel, burn fuel. Okay. I burn fuel at 3 times faster. So for example, person is a parent class and subclass is employee. Can it have old and new employee? Old and new employee. Yes, the car example is also okay. Yeah. So yes, you can have sports car here. So for vehicle, so simple, the generic nature is it can move on land, water, and air. And for car, so you have just the move method, it can only run on land. And for car, sports car, even this can move only on land, but its fuel burning rate will be 3 times faster than the regular one. Yes, you can create the method. And so now vehicle. So what the magic here is that vehicle V3 equal to new sports car So you can create a sports car object and assign that to your sports car variable or S car and the new sports car. This variable, or you can assign to car variable also, car to sports car and vehicle V3 new sports car. So that means your subclass objects can be assigned to, see, this is the parent class, this is the child class, car is, and this is a subchild. So even more, okay. So this is a grandfather, father, and child. So you can assign this child object to this parent variable, and this parent object to this grandparent variable. So assignment from here to here to here is possible, but creating an object for vehicle and assigning to this is not possible and not recommended. So something like, so I'm trying to assign sports car S car 2 equal to new vehicle. See? So type mismatch, cannot convert the vehicle to sports car. So you can't convert a vehicle to a sports car, but sports car you can assign to a vehicle, because sports car is of course a vehicle. You can't convert every vehicle to a sports car, but every sports car is a vehicle. So that's why your subclass objects, this is my subclass object, right? So sports car object can be assigned either to sports car variable. Sports car object can be assigned to its parent class variable, and sports car variable can be assigned to its grandparent variable also. Now, in this case, you have this new sports car V3. Let me rewrite this. I can move only on land, but with 3 times faster speed. Okay. So now I assigned this sports car variable to this V3. Now I'm calling this V3 dot move. Okay. So if I call V3 dot move, so I have this move method in my sports car and in my car, then my vehicle. So which one it should call? And how will it decide? So since it is having the same names in all the 3 classes, if this method is not there in this class, then it calls here. And if this method is not there, then it calls here. But if it is present in all the 3, then it takes the child method. So I can move only on land, but with 3 times faster speed. So I missed the times. So this is the result of my V3 dot move. So it called the appropriate method. So what if I comment this? Okay. So in my sports car, I don't have move method. Okay, let me comment the other objects creations also. I'm not interested here. So now let's run this as Java application. So I can move only on land. So then it called its parent class, right? So sports car parent class is car, and on this the move method is called here. So if it is not there even in this, then it will go here. Okay. So that is the sequence. So can we inherit subclass from 2 superclasses? That is not possible. That is, so you can't extend. So your question is like sports car extends car and comma some other class, right? So there is a superclass defined there, right? So this is called as multiple inheritance. This is supported in C++, but whereas in Java, the multiple inheritance is not supported. You can only extend at any point of time only one class. You can extend only one class at any point of time. Okay. So that is the concept of inheritance and overriding the methods from your parent class in subclasses. So you are overriding a method which is already present in your parent class. You are providing a separate definition, a different definition for that in the subclass. So that is called as method overriding. And when you are calling it on v3.move, v3 is of vehicle type, but On vehicle, you have this move method, but you actually, your intention is to call this move method. So your JVM is smart enough to identify, you assign this sports car object to this. So your intention is to call this method. So that is called as, so resolution of your method calls at runtime. So while execution, it will identify which method you are intended to call. And that is called as dynamic binding. Or so when we have the same method names in two different classes and one overriding the other, that is called as method overriding. And with one form, you're doing multiple actions, that is called as polymorphism. They look like same, but they do different actions. So public void move, public void move, public void move. The method is same. Method name is same. When the name is same and actions are different, that is called polymorphism. So here, so with same name but different actions, and resolving this issue when you are accessing the same method with the different variable. So which is the correct method to call? So that is called as dynamic polymorphism. At runtime, it decides which method to call. So that feature is related to method overriding. So method overriding, this is a method overriding. Same method name, same number of parameters, same type and order of parameters, and same return type as that of the parent class method. So you have seen all of them matching. Same number of parameters, no parameters in all the cases, and the same name and the same return type, void, and the same order of your variable parameters. Okay, of course here there are no parameters, that's why you don't see that. And similar to method overriding, under polymorphism we have one more concept called method overloading. You will have the same method, I mean you will have a method defined with the same name but with different number of arguments. Let's say have this move method, and in this public void move only, but move distance. Okay, so int distance. So if you tell how much distance you moved, it print the I moved distance. Okay. So now in the same sports car class, I have two move methods. One with no parameters and another with one argument. And you can define two arguments method also. So I move distance, this much of distance and this much of speed. I moved the distance with speed. So if you see here, the same method, move method only. So in my execution workspace, so if I call this v3.move, that will get called. So v3.move of, so I moved 100 kilometers. Yes, I will pass this. So So v3.move you can't call here with this one. Let me call it with scar. Okay. So scar dot move off, and this time, so 200 kilometers with 60 kmph. Okay. So having the same method name in two parent and child classes, that is called as method overriding. And having the same method name in the same class with a different number of arguments, this is called as method overloading. And so when you call scar.move with passing the 100 as argument, so it should identify which one to call. So whether this method or this method. So by looking at the number of parameters, your compiler will decide which method to call. So if it is only one argument, it will look for the move method in the sports car class. Are there any methods with the name move and only one parameter? So then identifies this and it calls this write method. So here the decision of which method to get called is decided at compile time itself. Compiler itself will decide. So this is called as a static polymorphism, method overloading. So from your interview perspective, so this is one of the most important question. So they will ask you, what is polymorphism? So achieving the different functionality by having the same name is called polymorphism. And under this polymorphism, you have two types. So one is method overriding and second one is method overloading. So method overloading is a static polymorphism because it gets resolved at compile time itself. Your compiler will itself decide based on the number of parameters. But if you see the move method, just the move method on v3 dot, so on v3 dot move, v3 is of variable vehicle type, but its object is sports car. But during your compile time, v3 is always your vehicle variable. So your compiler will not come to know at the time of compilation itself. So which move it should call. So this call will get decided at the time of runtime. So that is called as dynamic polymorphism. Dynamically at runtime it will be decided. But this will be decided during compile time itself. So we call this as a static polymorphism. So now if I run this, so I can move only on LAN, but with three times faster speed. I move distance 100 kilometers. So second move with 260. So I printed this forward. Okay, so it needs a little bit of practice, but yeah, this is the gist of these two concepts. So inheritance, polymorphism. Under polymorphism, you have two types. One is static polymorphism, dynamic polymorphism. So static polymorphism example is method overloading, and dynamic polymorphism example is method overriding. So these concepts are very, very, very important for your interviews.
Hey, Shiva, one question here. Now I'm taking scenario of method overriding.
Mm-hmm.
Uh, uh, as per my understanding, it follows the sequence of child to parent, right?
Yep.
So in that case, if the move method is defined under different classes but with different parameters, and then we are calling the move method,
Mm-hmm.
then will it look for the parameters to decide which one to run, or it will
It will look
follow?
for the parameters also. See, so how many parameters you are passing at the time of calling? If it's zero parameters, yes, it will look for only the methods that are defined with zero parameters.
Okay. So when it matches the method in case of overriding, it
Mhm.
matches considering the parameters also, right?
Considering the parameter count also, it is not like, so let's suppose if I don't have this move method here and um, I have a move method with 100 here, let's say int I here, okay, so then this method will not get called. Even if I call v3.move and that move is not present in sports car, it will not call this move of int I because it is expecting one parameter.
Okay,
But you are
okay.
not passing the parameter. It will exactly tries to match the signature without any parameters. That is called method overriding.
Hmm. Thank you.
Yeah. So from your interview's point of view, these two are very important topics. These are like, okay. So if you guys are clear, then I will move on to the next slides. So this is the basic gist. You need at least 2 to 3 programs practiced around this. So then only you can get some confidence. So I place these sample programs here, load them into Eclipse, and test them. Okay, give them a try. So whoever are coming from non-programming background, so they will have some fear towards Java programming language. So believe me, Java is not a rocket science. It's a simple like your SQL only. Only thing is there you will have a limited commands, maximum of 20 or so in SQL. But here you will see a bit more, 40 to 50 or something keywords, and 7 to 8 concepts like what is class, what is object, what is inheritance, what is polymorphism, what is method overriding, overloading, abstract classes, interfaces, collections. That's it. If you can spend almost like 20 hours, dedicated 20 hours, so that means one full Saturday and one full Sunday, you can learn it. It's not a rocket science. First, come out of that fear. So I'm not telling that you guys might be scaring, but I observed this with many people. Okay, so this is as per my general observation. I'm trying to motivate you. Just come out of that fear. It's not a rocket science. It's very easy only. Um, just try with basic, simple classes first. Then go to. So once you practice it for 2 weeks, then you will be good enough to write any complex like logic. If you know the basic usage of basic C language, the for loops, if-else conditions, and declaring some variables and using them, that's it. There is nothing more than that. Okay. So now, moving on to the next topic. So abstract classes. So while declaring sometimes the classes, you might be declaring the methods, but you might not sure. So what to write in that method? For example, in my parent class, so parent vehicle class here. So if I'm in a dilemma, whether what should I print here? So whether I should write like I can move on land, water, and air, or even something else, or I should keep it more generic. Okay, or I should leave it blank. So if you are in such a dilemma, and if you're not going to implement this, so Java allows you to even define a class without providing the definition for the methods. Okay, so it allows you to do that as well. So here I removed the definition for this, but so what you should do for that is you should make this method as abstract method. So then if you are not providing the definition or the body part of this method, then we call this method as abstract method. And if you have one such abstract method in your class, then you should declare your class also as an abstract class. See, now the error message has gone. So this is called as abstract class. That's it. So abstract class is nothing but if it contains at least one or more abstract methods. Abstract method is nothing but a method without the definition. It has the declaration, so only the signature declared, but not its body. Now, so I have another method like public void. So what could be? Yeah, manufacturer. Okay. Manufacturer is an attribute like move some accelerate or something. And in this, you have the definition for this. I accelerate at 10 kilometers a second or something. Okay. So in this class, you have a one method accelerate and one method move. So this move is an abstract method and this accelerate is a regular method. So for which you have provided the definition here. So that means abstract class can contain both the regular methods and as well as the abstract methods. So if it is having at least one abstract method in that class, then that is called as abstract class. Now, you can't create the object of vehicle directly in your workspace here. See here. So this is not possible. Why? Because this is not a regular class. This is an abstract class. Cannot instantiate the type vehicle because for abstract classes, there won't be constructor and you'll not be able to create the abstract classes will have constructor. Of course, they will have constructor, but you can't create the object for the abstract class. You cannot instantiate the abstract classes. You can assign this V1 with car this is possible. Your subclass. Car is my subclass. So which extends vehicle. And if car needs to use this vehicle class features, then it should implement all its abstract methods. So here implementing means providing the definition for the methods, abstract methods. Here the abstract method is move. I provided the implementation for that move method. And I can still call both move and accelerate methods here. I can call move, I can call move.accelerate. So if I call move, so this will get called on V1. If I call accelerate, this method will get called. That is the concept of abstract classes. So when you don't know the definition or the implementation of a method, you can define that method as a abstract method and class as abstract class. And if you want to inherit, if you want to extend that class, you should provide the implementation for the abstract method. So it printed the results there. I can move only on land, I can accelerate at this. Now, in case if you don't want to provide the definition for this in the car class also, if you remove this, then that means you are extending an abstract class but not providing the implementation for the abstract methods. Then either you should implement those abstract methods or you make your car class also as an abstract. And then provide your implementation for that in the subclasses. I provided the implementation for this move method in the sports car. So until then, even your car class is abstract class because you are extending an abstract class but not implementing the abstract method.
Shiva, I have a quick question here.
Yeah.
This one. Do we need an override then when we are extending abstract class and adding a method?
Yes, still you are overriding. You are extending this and overriding this method. There is no definition for this, but still you need the override here.
Okay, got it. Okay.
Okay.
So I mean, what is the use of this? Is this trying to enforce some rules or something?
Usage of abstract classes?
Yeah, since the definition is not there, is it trying to, if you are implementing?
Yeah. Okay. Yes, it is kind of enforcing a rule. If you are using this class, you should provide implementation for this method. That is the rule that you are enforcing there.
Okay, got it. Thanks.
Yeah. Okay. So now that is the abstract class. So when methods are declared in the classes without any body, they are called as abstract methods. A subclass always needs to provide the implementation of the abstract methods. If a class has even a single abstract method, then it becomes an abstract class.
Hey, Shiva, but what is the use? Just
Okay.
It didn't make any sense, right?
Okay.
We just have an.
So use is that you provide the common nature, so common operations, common methods that you can do in a one generic class. And if you don't know at the time of creation of that class how to implement that method, but still you want that method to be available there. So you can declare those methods in the class, and then you can later at some point when you want to use them, then you can provide the implementation.
But that's pretty dangerous because you're declaring at the parent level.
Parent level. Yeah,
Right?
later in subclasses, you have to provide your implementation at child level. So in parent level, there is nothing to worry about it. There is just the name.
Basically, you'll have to refine the whole program again, once you define the parent later.
Yeah. You have to implement the methods once again. So you will see the more examples in the coming slides. Okay. So the next topic is interfaces. In abstract class, you have seen in the abstract vehicle class, you have seen the definition or the implementation for accelerate method, but not for move method. But if I don't want to provide the implementation for both the methods, and I don't have, and I don't want to declare this as a class, yes, you can do that as well. There is an interface component called. So under that interface, you can declare all your method definitions, or just the method declarations, but not the implementations. Interfaces are pure abstract classes. You don't have not even one method which is implemented. And a class can implement an interface, but it cannot extend the interface. So here, if you see, I have an interface calculation. What this interface can do is, it can declare the two methods, add two numbers, and print. So these are the two methods that are present in my interface. There is no definition there is no implementation for these methods. But whichever class that want to implement these two methods, they can implement this interface. Public class simple calculation implements calculation. So now inside this class, I'm providing the implementation for these two, or the body for these two methods. Int add two numbers, return a plus b, void print int message. So result is this message.
So, sorry to interrupt you, Shiva here.
Yeah.
So if once I have an interface defined or declared all the methods,
Yep.
then let's say I've created a class which implements this one.
Yes.
But then you cannot go back and change the interface at all, right? You cannot add more.
You cannot add more methods to interface. Why not?
Yeah.
You can go and add more methods to your interface. Only
But then every
declaration.
class has to implement that then, right?
Oh, class has already implemented, then your subclass should implement those unimplemented methods.
No, so sorry. Let's say I have an interface. I have declared, let's say, 2 or 3 methods just declared, and then I created another class which implements that. Okay. But now I want to go back and add another method to the interface, or declare one. Then what happens to that class which implements?
That throws an error message.
Oh, okay. That means we should be very careful in doing that, right?
Yeah. So now let me define the interface, the calculation as well here. So actually, the public type calculation must be defined in its own, or I will declare this instead of public. So I will declare these two methods. Okay. Now I'm going to implement them in my simple calculation class. Okay, so here calculate, okay, this calculation. So the type simple calculation must implement the inherited abstract method calculation.print of string. Okay, so it should implement the string. So now your question is Control Shift F. So now it's not throwing an error message. Now what will happen if I declare one more method? Void move or show. Okay, so then as soon as I added a new method to this interface, so your class started throwing the error message saying that the type simple calc must implement the inherited abstract method calc.show. So that means it is saying that you didn't implement the show method in your class. So for that, what you can do is you can add unimplemented methods that it overrides this, and you can provide your definition here.
But if thanks, I know. But if I have in this example for simple calc, I can add a new method here, right? Okay, or I cannot. Without
you can add. Oh, in simple calc, you can add any methods. But
right, okay.
You can add one new method also. This is like your regular class only, but only this simple calc is like just like a regular class. But so with one condition that you are going to provide the definition for or the implementation for the methods that are present in this interface.
Okay. And what is the scope of this interface now? Is it across this package now, or only in this?
It's present in the package. If you declare that as public, you can use that in across the package or any outside of the package also.
Okay. Thanks. Yeah.
Okay. So you can declare some move method also in this, and you can do so anything here. Okay, you can create the object of this now, and you can execute that in your main method. So all those things I will be doing from here now. So in sports car, I can't do this. So since I removed that there, it has gone. So this is the interface concept. I defined all my methods in one interface, so which are common operations that I can do. And whoever wants to implement this interface, they should provide the implementations for all the methods that are present in this interface.
The implementation can be totally different for each class, isn't it?
For each class, it can be totally different. So now let me show you in real scenario, so where you can apply this interface concept. Let's say I have different shapes. Okay, I have a circle. Okay, one object which is of circle shape, which is a square shape, which is a rectangle shape. Okay. Now, common to all these shapes, there will be a method or area, right? So get area. But the implementation is different for circle. Circle is, it's a pi r square or something. And for this is r square or something, square. And this is height and length and width, right? Length into width. So implementation is different for area method, but you need the area method present in any of these shapes. Now what I can do is interface shape And in this shape interface, so I can define the area method, so which returns an integer value or double value, and it should have an area method. No matter whatever the class or whatever the shape that you are going to deal with, that should implement this area method. Now, if you are writing class circle, implements interface, implements this shape, you should provide the implementation for your area method differently here. And in your class square, you should provide the implementation for area method there differently. And you should provide the area method implementation for rectangle separately in that. But you must provide as long as you are in you are belonging to any of these shapes.
Yeah.
The method name is same. So here you are not sure which method, which implementation you should provide. So I just declared that method name. That's it. And I provided the definitions in this.
Okay, got it. Thanks.
Okay.
That's good. Yeah.
Next. So that's the concept of interfaces. So I want you to give it a try. Next. So reading through the files. So IO operations. So input output. So as I was telling even today, I think, right? So in order to read from any source, you will have a input stream. Stream is nothing but the flow of your characters or bytes. So input stream, you are reading input. So output stream for writing your output. Input stream to read data from a source, one item at a time. Output stream is used to write data to a destination, one item at a time. Now, here the types of input-output streams, there are many. So the byte streams are there, which read byte by byte. And character streams read character by character. In some cases, these two will be of similar, but there can be some characters which are more longer than one byte. So if you read one character like double or float, so that is like 64 bytes, but still that is one character. Or there will be some characters which will be of 2 bytes, 3 bytes, 4 bytes also. So byte by byte means you will read 1 byte at a time. And character streams means you read 1 character at a time. Here, in these 2 streams, there is one disadvantage. So for every byte or for every character, you have to make an IO call request. So if you have 1,000 characters, you have to make 1,000 times request for read. In the buffered streams, instead of making the 1,000 IO call requests for reading the 1,000 characters, in the buffered stream, what it will do is, with one input operation itself, it will read a 1,000, let's assume buffer size is 1024 bytes. So it reads 1024 bytes, entire 1024 bytes into memory or some buffer space. From there it reads that. So it reduces the number of IO calls to the hardware. So the buffered streams are more preferred ones. And scanning and formatting, IO from the command line. So these are not much useful in real time. So scanning and formatting might be sometime, but in real time scenarios, you will not be displaying any of these things on the console or something like that, right? So command lines are of less priority, but let me show you these things. And data streams and object streams. These two are for dealing with binary binary data. These two are for the regular data which you can read and write, but this is for dealing with binary data. So this is why. So you have seen in your Hadoop class in HDFS Java client, I was showing you FS data input stream. That is data stream, and FS data output stream. Okay, let me show you some examples here. So under byte streams, you have a file input stream and file output stream classes. So here the input stream and output stream are the abstract classes. They will have the methods and their implementations. So file, if you want to read a file byte by byte, you can utilize this new file input stream object, or the file input stream is the class. And to write to a file byte by byte, file output stream is the class. And similarly, if you want to read a file character by character, then you have file reader class available. And if you want to write character by character, you have a file writer. But these two are not directly be used. These things will be used along with the buffered streams, something like this. So, but because buffered, so each read or write request in unbuffered I/O is directly handled by underlying operating system, resulting in less efficiency. Frequent disk or file access is relatively expensive. But in buffered input-output, a separate memory area is maintained as a buffer, and into that buffer, you will read some chunk of data, and then you will process that. So buffered input streams read data from the buffer until it is empty. Okay. So you don't need the concepts that much of these things, but of course having a basic idea. So if you have a sample input.txt file, okay. So if I want to read this, if you want to read by character, go for the file reader. If you want to read by byte, go by the file input stream. So before reading from this, you should get that into buffered reader first. You should get that into buffer. So instead of making for every character, making the OS operating system call, you get that with one buffered request, get that into one buffer, either 1024 KB of data into this. So reader equal to new buffer reader, new file reader of sample input.txt. So one can convert unbuffered streams into buffered streams by wrapping the unbuffered stream object into the constructor for a buffered stream class. And similarly, this is for writing. So your file writer will keep on writing into the characters by characters into the buffer, and that will write through buffer writer into your actual the file location. This is for characters, and we have buffered input stream and buffered output stream to deal with bytes for byte streams. Okay, so this is important. Let me show you one example there. So string buffer example, not this one, write to file is okay. Parse CSV file example. Or, okay, I think yeah, read file is also there. See, you have this. I have a file in my C directory. If I want to point to any location, so string buffer. Why do you need file input stream? New string buffer of empty content. So this is file input stream. If you want to read byte by byte, so new file input stream of the file object. This file object takes the path and you're passing this. So to read bytes from stream, use the read method. On this file input stream object, so I can read fin.read, read method is there. So it reads byte by byte. I am getting that into this character. So int ch. If it is not equal to -1, that means not the end of file. Okay, string content dot append of char of ch, converting that byte value into the character. This is a casting. So if you prepend this data type char, it will get converted into char. And you are converting that into string, and you are taking that is completely reading that file and appending into a string. And this is second way of reading. So new file input stream, file, and buffered reader. Okay, and in this reader, yes, r.readLine is to read line by line. And this also explains the exceptions as well. Let me refer those as exceptions next coming slides. Similarly, you can see the write.test. You have specified the path, file path in the string. That string is there. So file output stream is specified here. And either you write byte by byte, byte b equal to 0, 1, and writing that byte into this file. Either that is okay, or you make it as a buffered stream writer. Read file. This is a parse CSV file. Yeah, maybe this is a good example. So you're trying to read a CSV file. So create a buffer reader to read the CSV file. New file reader of string file. The file path is given there. File reader, new file reader, new buffer reader on this, and read that. There is a string tokenizer also available, which tokenizes, which splits your strings by a delimiter that you are specifying. Okay, so I declared a string tokenizer here, line number. So I am reading from this br buffered reader br.readLine. So this reads line by line. So while str line br.readLine, you're assigning this, while this br.readLine is not returning the null value. So that means it is not reaching the end of the file. Until then, loop through this. Okay, so line number plus plus, new string tokenizer, string line comma, and has more tokens. So this is on string tokens, and print them. This stuff. Okay, so I want you to run this as part of assignment. Okay, so running this program from your Eclipse, create a file in your desktop, get the path, provide that path here, and read through this program and debug this program. So I have shown you how to debug the Java programs, right? So put the breakpoints or line by, just run debug as, and then see so how the control flow is moving line by line, and see the intermediate results, and show me a couple of screenshots for that. Okay, there is nothing, no result to give this. Just show me the debugging screenshots and whether you understood it or not.
Siva, this is Ramchandra here.
Yeah, Ramchandra.
Can you please share this week videos and last week videos Java classes?
Yeah, they are there in the. Oh, okay, you are not part of the Hadoop training batch, right? Actually,
Yeah.
I planned these Java sessions only for the Hadoop batch guys. Okay.
Okay.
So that's why I put them in the Hadoop folders. But no problem, I will share it with you as well. Okay.
Yeah. Thank you.
Yeah. And
In that, I can get the examples also, right?
yes, you will get all these examples. So all these, and I want everyone to run all these examples. Prepare necessary inputs for them, run them, and I need the screenshots for your results.
Yeah.
Okay. So that's the assignment for this Java Part 2 session. Okay. So next, let me take the collections concept. So collection is nothing but a container or a placeholder for a group of similar type of elements. Okay, so used to store and retrieve and manipulate and communicate the aggregated data of similar type of elements. So here iterator is one keyword that you will see, is used for traversing a collection and selectively remove elements. So generics programming, as I was telling you, so all these collections are defined with generics. I'm not going much deeper into the generics concept, but so how much ever is needed for here, so that I will complete. So till now you haven't seen this this angle brackets, right? So list of string. So list of string, this is nothing but a one array list. Anyway, before going to the discussions, let me take the next interfaces. So collection is my super interface. Under that, I have a set interface and list interface and queue, this basic ones. Okay, and I have a map. So generally, when we talk about collections, these are the four things that we discuss: set, list, queue, and map. Okay, so list is nothing but a variable length array. So array is nothing but fixed length array, right? So once the size is fixed, that's it. You can't increase the size of an array. That is the difference between your arrays and lists. This is again one of the commonly asked interview questions. Okay, so the difference between array and list. Between arrays and array lists, or we also call this as a array list. So array, at the time of array declaration, so we'll have this string array arr equal to new string of 10. That's it. You can't increase the size of this array. Once the array is filled, if you want to add one more element, you need to declare one more array with 20 size and move all these 10 elements to that array. So that's the reason why people don't use arrays much. So if you want to have a dynamic array list, so you can declare that. So this way, list of string. So list new array list. So here array list is list is an interface. Array list is the class that implements the methods that are present in this list interface. new string of, can declare this way. Okay. That is all about the. So I hope you got the difference between the array and array list. Okay. So now array list can have similar type of elements. If I need to declare strings into list, you can do this. List of employee names or list of employee IDs if you want, then you should have integer. ID list, new array list of integer. Okay. This way. And if you see, so that is about list. Now coming to the set, it is also a collection of similar type of elements only, but it will not contain the duplicates. Whereas list can contain duplicates also. Okay, so duplicate employee names can be added to the list, but duplicate employee names cannot be added to the set. So if you declare this as a set, set of the string and names, new hash set. There are some implementations for these interfaces. Okay, so don't worry about the backend logics, how they got implemented, so how they are implemented, how their logic is in the backend. But coming to the functionality side, list is a collection of elements which can accept the duplicates also. Mainly you should know the difference between arrays and array lists, and difference between set and list, and difference between set and map, all this stuff. Okay, so set is nothing but a unique list of elements, and queue is nothing but first come, first serve, first in, first out. So you will be processing the elements in the same order in which you inserted that into the collection. And here coming to the map is nothing but a key value pairs. So your employee IDs are keys and their names are values, something like that. Now the basic operations that you can do on collection interface, the size is a valid method on a collection, and isEmpty is a valid method on collection. Contains, add, remove, iterator. So size will return how many elements are there. Whether your collection is it could be a set, or it could be a list, it could be a map. So isEmpty, it returns whether your collection is empty or not. Similarly, some of the bulk operations that you can do, whether your collection contains another collection elements or not. If you have two collections and calling this contains all method on one collection, whether it contains the second collection or not. Add all one collection elements to another collection element. Remove all, removing a one collection elements from the other collection elements. And clear on the collection, it removes all the elements from the collection. So these are the collections that you have seen. So these are interfaces. Collection, set, list, queue, and sorted set are interfaces. Now, their implementations, we should have classes, right? If you have only interfaces, you can't create the objects and you can't call the methods. So Java has provided us the methods for the implementations for these interfaces as well. So for set, we have hash set. For sorted set, we have tree set. Now, the difference between hash set and tree set, you will have elements in sorted order in tree set. Here in set, you will have the elements, the unique elements, no duplicates, but no guarantee of sorted order. Similarly, for lists, you have two. One is array list and second one is linked list. Array list is something which is used for fast retrieval. And linked list is for if you have more insertions and removals, insertions and removals are there, then linked lists are preferred. Okay, so there are some theory also behind this differences between these two, but performance wise, if you have more retrieval purposes, so one time addition and after that it's keep on reading, you will choose array list. Otherwise, you can dynamically add your elements at any position, and if you want to remove those elements, you should go for linked list. But most of our programs, 90% of the cases, we use array lists only. But in your interview questions, what will be the questions are like? So difference between set and list, and difference between hash set and tree set, and difference between your array list and linked list. Okay, so array list and linked lists are used only for when you have more number of insertions and removals, and array lists are used when you need fast retrievals. And difference between set and map, or difference between list and map. Map is a key value pair, and whereas this is just a collection. So here again, in this you have two types of maps, hash map and tree map. The difference between hash map and tree map, so hash map is a simple key value pairs, and tree map is again key value pairs, but here the keys will be sorted in ascending order. Okay, so I have given you the examples once again here. Okay, let me show you example at least for that to test. Add element to specific bubble sort, calculate collections test.java. See, here I have created a collection. So L1, list 1. So new array list of integer, and added L1.add of 10, L1.add of 20, 50, and this is a linked list. I created this and loop through that and printed those values. So for integer I in L1, I printed all of them. L2 dot contains 500. If my list contains 500, then I printed yes, 500 is present. Similarly, I created the set here. This is an example for set creation and addition of elements. This is an example for tree set and addition of elements. And print them here. So here you will see that here the elements may be of any order, but here in the tree set, if you print them, they should be in sorted order. Okay, so I want you to execute this stuff. Next, coming to the exceptions. So
Shiva,
yes, Anand.
before, quickly, let me know if it is earlier question, but where in Hadoop world, where would you use these arrays and these what
Collections,
scenario?
yes. You will see them from tomorrow class onwards in the MapReduce program.
Okay, it will be part of MapReduce. Okay,
Yes.
perfect. Okay.
So collections are needed. Lists, I will be using array lists. Okay.
And that is all. That is all done.
Yep.
Okay.
So the next last concept for today's session is exception handling. So exception is something that is a problem that occurs during the execution of a program. Generally, suppose if you are reading a file and you have given a path, in that path the file is not there. So that is an exception. And you are trying to open a file, or you're trying to read a file, but that file is an empty. Okay. Or you're trying to write to a file and you don't have write permissions to that file. Or you are trying to divide a number by 0, that gives an exception. Null pointer exception. Some exception. Okay. And you are trying to assign, or you have used a string and you are using that string in arithmetic operations. String cannot be used in arithmetic operations. That time you will get null pointer exception. So some problem that happened during the execution of your program, that will be raised as an exception. The problem can occur because a user has entered incorrect data, whether you have incorrect data, or a file that needs to open does not exist. It could be any other scenarios. Java virtual machine has run out of memory exception, or network connection failed. And these exceptions, coming to these exceptions, so we will receive these messages which is of two types. One is of error and another one is of exception. These two are the subclasses of your throwable. Under exception, you will see IO exceptions and runtime exceptions. IO exceptions are file input output exceptions, whether your input is existing or not, the file not found exception, file not opened exception, so those things. Runtime exceptions are like memory out of exceptions, memory is not sufficient, null pointer exception, using strings in arithmetic operations, or array index out of exceptions, you're trying to access beyond the size of your array. Okay. This is example for null pointer exception. So if you feel like a particular piece of code can throw an exception, so what we'll do is, so we'll put that code in a try block. So try this code, and if it throws an exception, catch that exception, catch exception, and so that means the exception is raised. Now you can do whatever you want to. I mean, so you should tell your program what you should do next. So here simply string null and int n string dot length. So on string, you're trying to, this is a null string, there is nothing. So in that you can't get the length method. So that throws an exception as it. And this is a null pointer exception. And e dot print stack trace during our exceptions in the catch methods, it is helpful for printing the stack trace, like, so all the messages, appropriate error messages or exception messages. Okay. So integer parse exception. So I have a string 10, and the string I'm trying to parse it as integer, which is a incorrect operation. This throws this kind of exception. So in our exceptions, we'll have a try block, catch block. So if anything fails in this try block by throwing an exception, then your control will go to catch and then will come out of the program. Now, there is one more block which is called finally. So finally block, irrespective of, so let's say you have opened a file and you are reading that file, and while reading, you got an exception. And you will go into catch block and you will come out from there. So your file is not closed. Okay. And in such scenarios, you can have a finally block. So even if the exception is erased, so if file not found exception is erased, this catch block will get executed. If other than file not found exception, if it is some other exception, then this block will get executed. So in both the cases, if you want to close the file, you can have a finally block here. And here you can close here. So whatever the file that you have opened here, so FIL is there, right? So this is what you have opened there. So FIL dot close. So coming to the control flow, first the try block will get executed. If there is no exception, then the finally block will get executed. After that, here's this statements will get executed. So in case of exception, so you got an exception in this line, then so this catch exception got matched and this is printed, and then your control will come to finally and it will come out of the program. It will not execute these lines. Okay, so I know this is a very quick revision of these concepts. So it takes at least, 10 hours to practice on all these programs. So that's why I have listed down, I have collected all the programs, each of these topics, for interface, for inheritance, for sets, for maps, for collections, for searching, for writing into a file, for abstract classes, for maps, for linked lists, all these things, reading a file, writing a file, all these things. Okay, so I want everyone to go through this list of programs and understand. Believe me, you will be in a good shape. If you run these examples in your Eclipse, don't get lazy. Run through each of these programs from your Eclipse and understand each and every line of these things. And you might see some new keywords here and there. Just Google them, and even after that, if you're not getting them, just reach out to me. I will help you out during our regular sessions itself. Okay, so most of you are silent, I know. So the reason why is like, first come out of that fear or scariness for the programs.
Shiva, one question.
Yeah, Nitu.
You will be starting MapReduce from today itself. So, will I be able to follow that before I?
Yes, obviously. At least you will be You need to practice these collections. Just run these, understand, go through the collection slides and this video once again and practice these examples. You will be able to catch everything. So once you practice these programs, just copy them, load them into your Eclipse, run them. Okay, debug the line by line and try to understand the line by line. These are not very bigger programs, all are smaller ones only, okay? Very simple programs, just as simple. So it needs some package concepts also. If anyone faces any trouble in running these things, I can help you out. Not an issue. Okay, so in case, again, if you need in a 1 hour session or so to clarify your questions, if you feel like you guys have more questions on these areas, I can schedule one more 1 hour session on next week to clarify your questions. If you have any questions on the topics that you are going to refresh now. Okay, so for your MapReduce sessions, so no worry. So I will guide you there. You don't need to worry. You will get definitely. Okay, and as I'm recommending you, you don't need to learn the MapReduce from programming perspective, at least for now, because these days we are not using MapReduce that much effectively for programming. But you need the concepts, the background of the parallel processing. So that is what being used in even in Pig and Hive and Scoop and DistCP, all other tools. So you should understand those concepts.
Shiva.
Yeah.
So Shiva,
Yeah.
the homework we submitted, you're going to review those?
I quickly gave a glance over that. I skimmed through that, but I didn't really read each and line by line. Okay, so I have gone through. So you asked about the what is URI. URI is nothing but your URL. Something like your website URL is there, right? So here you are using HTTPS. This is your URL. But in your HDFS, what is the URL? URI HDFS : / your name node : 8020 followed by your path. I have shown you that, right? I mean fs.defaultfs. That is the URI. Okay.
Okay.
And for other questions, I will try to answer these things in our. Please remind me. I will try to answer these things in the sessions itself, so that if even others also having the similar type of question, they will also get clarified.
Oh, great. And then I have some issues with a couple of commands, so we'll talk that in the session then.
Yeah, in the session itself. Okay. Yeah.
No problem. And Shiva, one more thing. The shared drive on the VMware, not working. Do I need to install any VMware tools? I googled around, but I didn't found much.
Shared drive.
Yeah, see, when you have like a local drive, if I want to copy a local file to my VMware, that one.
It's not allowing you.
I mapped it, but it doesn't show into that folder, TNT folder, right? No, MNT folder, right?
You don't need to map it also. You can simply drag and drop.
Oh, okay.
See, simply drag from your Windows machine into your Linux. It should get copied. And or right click copy on Windows machine and right click paste on your Linux machine. It will get pasted. If you are using VMware Workstation.
Yes, I'm using VMware.
Yeah, it will work. I will show you this tomorrow in case.
No problem. Perfect.
Yes.
Thank you for the session, man. This was good.
Yeah. Thanks.
I think we'll definitely need one more 1 hour session probably.
Yeah, maybe come up with your questions if you feel like you guys need a 1 hour session for clarifying your questions. Then let's discuss. Okay. So come up with some real problems. Practice them. So don't simply come like, I need 1 more hour session. Okay. Come up with what is the issues that you are facing. So based on your curiosity, I will spend 1 more hour or something. So these Java sessions are completely complementary for all others. That's why even I included the Spark batch guys. Yeah.
Thank you, Shiva.
Yeah, thanks.
Shiva, please send me that access, Java.
I will share this access to you as well, Ram.
Yeah.
Sure.
Thank you.
Okay. Bye-bye. And with you, Ram, I will talk to you tomorrow. Okay.
Yeah.
So, yeah. And Srinivas also, I mean, after tomorrow's class, morning class, let's connect with your Impala problem, Srinivas. Right now, I'm a bit feeling like a bit tired and headache because I had morning class and evening class. Little bit feeling headache. Okay.
Actually,
tomorrow morning after 9 o'clock.
After 9, Shiva?
Okay. Tomorrow morning. Just tomorrow morning.
Yeah. Okay.
Yep.
If suppose tomorrow evening is possible, Shiva, then...
No. Evening I will have calls from 5 p.m. to...
okay.
Yeah.
Okay.
5 p.m. to 10 p.m. So morning is fine for me. So after session, 9 a.m., so I can spend some time.
Okay.
Okay. Yeah.
Okay.
Thanks. Yeah. Thanks everyone. Bye-bye.